Fajans rule. To learn Fajans rule, let me give you one example. Consider this man pulling this sack. We know that when we pull something soft, it usually gets distorted or deformed. Similarly, this man is pulling this sack and it gets deformed. Now consider these positive and negative ions. Here, the size of cation is smaller and the size of anion is larger. Now this positive ion or cation attracts these electrons of the anion. Let me repeat it. This positive ion or cation attracts these electrons of the anion. As a result of this, the electronic cloud of anion gets deformed or distorted. I mean, this cation is like a man pulling the sack of electrons and it gets deformed. Here we use three important terms: polarizing power, polarizability, and polarization. Remember that we use polarizing power for cations, polarizability for anions, and polarization for electronic cloud. For instance, I say polarizing power is the pulling ability of a cation. For example, if this cation pulls the electron of anion strongly, we say that it has more polarizing power. So we define it as the ability of a cation to polarize the nearby anion. Secondly, I say polarizability is the deforming ability of an anion. For example, when this anion experiences strong pull of the cation, it will be highly deformed and its polarizability will be high. So we define it as the ability of an anion to get deformed by the cation. Thirdly, we define polarization as the distortion of the electronic cloud of an anion towards cation is called polarization. For example, this electronic cloud tilts towards the cation. As a result of this, more electrons are at this side. So partially negative charge appear on this side. At this side, less electrons are present, so partially positive charge appear on this side. Thus we say that this anion is polarized due to having partially positive charged pole and partially negative charged pole. Therefore noted down all these basic and important concepts. Now what is Fajans rule? Well, consider ionic bond. We know that ionic bond is formed between cation and anion. Here, this cation will attract these electrons of this nearby anion. As a result of this pulling, the electronic cloud of this anion will tilt towards cation and anion is polarized. Now listen carefully. These electrons look like that they are shared. Let me repeat it. These electrons look like that they are shared. We know that sharing of electron is the property of a covalent bond. But here it seems that these electrons are also shared an ionic bond, due to which we say that partially covalent character exists an ionic bond. Thus remember that some covalent characters are present in ionic bond. Now Fajan rule shows the amount of covalent character present in ionic bond due to polarization of ions. Let me repeat it. Fajan rules shows the amount of covalent character present in ionic bond due to polarization of ions. For example, consider Mr. Shimel. We know that he carries both the character of male and female. Similarly, Fajan Baba teaches that ionic bonds also carry some character of a covalent bond. In conclusion, we learn that no bond is 100% ionic or 100% covalent. Rather, covalent and ionic are relative terms. I mean, they both exist at same time in any chemical bond. Now let me teach you that how can we determine covalent character and ionic bonds. Well, firstly, Consider cations. We know that cations have polarizing power or pulling power. The first factor of cations affecting covalent character is the size of cations. For example, consider these two ions. The size of this cation is smaller. It will easily pull the electrons of anions. Hence, its pulling power is high, its polarizing power is high, and it has more covalent character. On the other hand, the size of this cation is larger. It will be difficult for it to pull the electrons of anion. Hence, its pulling power is low, its polarizing power is low, and it has less covalent character. Thus, remember that the smaller the size of cation, the greater will be the polarizing power and covalent character. For example, consider this case. Which ion has more covalent character? Well, lithium has the smallest size and potassium has the largest size. So lithium has more covalent character than sodium and sodium has more covalent character than potassium. The second factor is charge on cations. Consider these cations. We can see that this cation has more positive charge. It will love to pull more electrons of anion. Hence, its polarizing power is high and it has more covalent character. On the other hand, this cation has less positive charge. It will hesitate to pull more electrons of anion, or it doesn't love to pull more electron of anion. Hence, its polarizing power is low and it has less covalent character. For example, consider this case. Which ion has more covalent character? Well, aluminium has positive 3 charge and sodium has positive 1 charge. So aluminium has more covalent character than magnesium and magnesium has more covalent character than sodium. Thus remember that the more the charge on a cation is, the more is its polarizing power and the more it has covalent character. The third factor is pseudo-noble gas configuration. But I will not teach you this concept because it is both boring and difficult for students. I teach them the third factor as superhero cations. I mean, these superhero cations has the highest covalent character in the periodic table. One family is coinage metals and the second one is zinc family. Whenever you spot these superhero cations, they always have the highest covalent character. For example, consider this case. Here, the anion is the same, which is chlorine. The cation is copper and sodium. We know that copper is a superhero cation. So copper ion has more covalent character than sodium. Therefore, copper chloride has more covalent character than sodium chloride. Hence, note it down all these important points. Now, I will teach you properties of anions affecting the covalent character. We know that anions have polarizability or deforming ability. The first factor affecting covalent character is size of anions. Let's consider these anions. We can see that the size of this anion is smaller. It will not easily be distorted or it will deform less. Hence, its polarizability is smaller and it has less covalent character. On the other hand, this anion has larger size. It will be easily distorted or it will be easily deformed. Hence, its polarizability is high and it has more covalent character. For example, consider this case. We know that the size of bromine is the largest and that of fluorine is the smallest. Hence, bromine has more covalent character than chlorine and fluorine. Thus, remember that the more the size of anion is, the more is polarizability and the more is covalent character. The second factor affecting covalent character is charge on anion. Let's consider these ions. We can see that this anion has less negative charge or less electrons. So it will not easily experience the force of cation, or it will not be easily deformed. Hence its polarizability is low and it has less covalent character. On the other hand, this anion has more electrons or more negative charge, so it will easily experience the force of cation, or it will be easily deformed. Hence its polarizability is high and it has more covalent character. For example, consider this case. Here, the charge on oxygen is double negative and the charge on chlorine is single negative. Hence, oxygen has more covalent character than chlorine. Therefore, remember that if charge on anion is high, it has more polarizability and more covalent character. Thus, note down all these important points. Now, let me teach you some important MCQs of Fajans rule. Also remember these important points about cations and anions. If the size of a cation is smaller, it will have more polarizing power and covalent character. Secondly, if the size of an anion is larger, it will have more polarizability and covalent character. Now consider these ionic compounds. Find the order of increasing covalent character. Well, here cation is the same, which is sodium. So I only consider anion. We know that larger the size of an anion, more is the polarizability and covalent character. The size of iodine ion is greater than bromine and chlorine ion, so this is the order of increasing covalent character. Secondly, in this case, anion is the same in all ionic compounds, which is chlorine. So I only consider cations. We know that smaller the size of a cation, more is its polarizing power and covalent character. The size of lithium is smaller than sodium and potassium, hence this is the order of increasing covalent character. Thirdly, in this case, the anion is the same, which is fluorine. I only consider cations. The size of beryllium is smaller than magnesium and calcium, hence this is the order of increasing covalent character. Fourthly, we know that the larger the charge on a cation, the more is its polarizing power and covalent character. Hence silicon has highest charge and sodium has lowest charge. Thus this is the order of increasing covalent character. Also consider these questions. Which cation has more covalent character? Well, we know that copper is a superhero cation. So copper has more covalent character than sodium. Secondly, silver is also a superhero cation. So silver has more covalent character than potassium. Thirdly, cadmium is from a zinc family. It is a superhero cation. So cadmium has more covalent character than calcium. Fourthly, gold is a superhero cation. So gold has more covalent character than rubidium. Thus note down all these important MCQs. Now let me teach you the application of Fajans rule. Well, to learn its application, we must learn some important questions. Why ionic bond is soluble in water in most cases? Well, the answer is simple. It is because ionic bond is polar and water is also a polar solvent. We know that like dissolve like, hence many ionic bonds are soluble in water. Secondly, why ionic bond has high melting points and boiling points? The answer is simple. It is because of strong electrostatic force of attraction between ions and ionic bond. Thirdly, why covalent compounds are colored? It is because covalent compounds absorb energy, then electrons emit radiation in the visible spectrum, due to which they are colorful. Now, in the light of these facts, we can say that if covalent character increases, solubility of ionic compound decreases, because they will be less ionic and more covalent. Secondly, if covalent character increases, the melting point and boiling point of ionic compounds decreases. Thirdly, if covalent character increases, the color imparting ability of ionic compounds increases because covalent compounds are colorful. Thus note down all these important points. Now consider these important questions. Which will have a higher melting point, sodium chloride or copper chloride? Well, we know that the anion is the same in both the compounds, which is chlorine. I select the cation. We already know that copper is a superhero cation. So the covalent character of copper is more than sodium. Hence copper chloride has more covalent character than sodium chloride. We know that when covalent character increases, melting point and boiling point decreases. The sodium chloride has high melting point than copper chloride. Secondly, which is more soluble? Iron 3 hydroxide and iron 2 hydroxide. In this case, both the cations and anions are the same, but the oxidation state of iron is positive 3 in this compound and positive 2 in this compound. We know that the greater the charge on a cation, the greater will be the covalent character. Hence, iron 3 hydroxide has more covalent character than iron 2 hydroxide. We know that when covalent character increases, solubility decreases. Hence, iron 2 hydroxide is more soluble than iron 3 hydroxide. Lastly, which one has the darkest color? Silver fluoride, silver chloride, silver bromide, silver iodide. Well, cations are the same in all compounds, which is silver. We know that the size of iodine is the largest and the size of the fluorine is the smallest. So this is the order of increasing covalent character. Silver iodide has the highest covalent character and silver fluoride has the lowest covalent character. We know that when covalent character increases, color imparting ability of ionic compounds also increases. Hence, silver iodide has a dark color. Thus note down all these important questions. Finally, let me teach you one bonus concept like limitation of Fajans rule. Remember that Fajans rules is a qualitative law. It means that we cannot find the numerical value or percentage of covalent character in ionic bond. For example, we cannot say that 50% or 70% covalent character in ionic bond. Rather, we only summarize covalent character in ionic bond. I hope that you have learned all about Fajans rule.